Thomas Bending, teaching MS3620 Financial Statistics. It carries on from MSO 2620 Financial Mathematics, which you'll have done in the second year, looking at the same areas of interest systems, time series, portfolio selection, that kind of. The difference between the two is that the second year module, it's a discrete mathematics where interest rate prices go in steps. At the third year, we're able to look much more at continuous processes, which can be easier to analyse in more detail, where interest rates vary continuously, prices can vary continuously, and so on. Have to have done the second year financial mathematics module. The third year one carries on from that. It really doesn't make sense without it. If you like the second year module and were good at it, you'll like the third year module and be good at it. If you didn't, you won't. We look at Markov chains as a way of modelling finite state systems. They can be used in several areas of financial statistics to model problems. We look at portfolio selection in more detail with more than two stocks in the portfolio, a much more realistic model of how people do hedging in the real world. And we start looking at game theory as a way to model interactions in business where your opponent is trying to outwit you, trying to make cleverer decisions than you, and you have to see if you can beat them. There's an individual coursework worth 25% in two parts, one in each term, solving a series of problems to do with the material in the module. There's a group coursework also worth 25%, modelling share prices over the year, rather like the one in the second year, but this time we're using them to form a portfolio and trying to analyse how we can get the best possible portfolio of those shares to balance risk against return. And then there's a formal exam at the end worth 50%, a 3-hour unseen exam, where we ask you to again analyse problems but also tell us a bit about the theory behind what you're doing. It's a mixture of specific techniques for accounting and economics, for example using Markov chains to model systems, some of the probability you'll be studying, ways to use time series and forecasting, but also a lot of the techniques will be more generally applicable. A lot of the stuff you learn about probability and game theory, some of the techniques using computer packages to solve problems have a much wider range of applicability across all sorts of fields. It gives you a much clearer picture of how the mathematics and statistics underlies techniques that you're using. A lot of people in accounting and economics can use these techniques but don't necessarily understand where they come from and can't deal well with it when they go wrong. It's important to be able to understand that if you're going to use them well in practice.